Now the next terms to be discussed includes mole fraction, molarity, molality and normality. So first of all, let's see what is mole fraction. Mole fraction is defined as the ratio of the number of moles of a particular component divided by the total number of moles of all the components in the solution. For example, suppose we are taking solute. We are taking the mole fraction of solute. Let us denote the solute as A. And let's denote the solvent as Appo mole fraction of solute endana? It is the number of moles of solute divided by total number of moles of the solute plus solvent. Okay, that is mole fraction. We denote it normally by X. Okay, XA, the mole fraction XA is what? Number of moles of solute A divided by what is the total number of moles? Number of moles of A plus number of moles of B. Number of moles of A plus number of moles of B. Okay, got it. So this is mole fraction. If we have to find the mole fraction of solvent, what should we do? We have to find XB. XB is NB divided by Na plus Nb. This is the number of moles of solvent and this is the total number of moles of components in the solution. That is Na for solvent, Na for solute and Nb for number of moles of solvent. Okay. Now let me ask you a question. What will be the sum of the mole fractions of all the components? It is 1. I will show you. This is XA. This is mole fraction of the component A, that is solute. So this is XA plus this is XB. XB is mole fraction of solvent. Okay, this is XB. Now what should we do? Let's add this to find the sum of the mole fractions to see whether it is unity or not. See. What is XA? It is Na by Na plus Nb. What is XB? It is Nb divided by Na plus Nb. What is this? Na plus Nb divided by Na plus Nb. This is unity. So the sum of mole fractions of all the components in the solution is unity. Okay, it's important. So if we are given the mole fraction of this solvent, we have to find the mole fraction of the solute. What should we do? We know XA plus XB is equal to 1. So XA is equal to 1 minus XB. Just subtract the value of other components from 1. Okay. Now this is clear. Now next is molarity. It's very much important. Molarity means it is the number of moles of solute. If we are considering solute, it is the number of moles of solute per unit volume of the solution in liters. Unit should be liters and we are considering it out of solution, not out of solvent. Okay. So molarity is number of moles of solute divided by volume of solution in liters. I hope it's clear for you. Okay. Now next is molality. See the difference, just a difference of R and L. Okay, molarity and molality, the concept is entirely different. Should not confuse. Okay. So next is molality. Molality is number of moles of solute divided by the mass of the solvent in kilogram. Should not confuse. Molality. Molality is number of moles of solute divided by what? divided by weight of the solvent in kilogram. Should be in kilogram. Oh, sorry, I didn't write the equation for molarity. I will write, otherwise you will be confused. This is molarity. Molarity and molality, see the difference? This is number of moles of solute divided by volume of solution in liters. So even if there is a difference of R and L only, this is a huge difference. One is the weight of solvent in kilogram and the other is volume of solution in liters. Okay. So this is molarity, molality and mole fraction. Next important term is normality. This is not in our textbook but in laboratory activities, lab activities, we have to be familiarized with this too. Normality is number of gram equivalents divided by volume of solution in liters. Normality of the solute is equal to what? Number of gram equivalents. Number of gram equivalents of solute, which is of solute, divided by volume of solution. Volume of solution in what? Same as molarity is the volume of solution in liters. Okay. Number of gram equivalents. In case of molarity, what did we say? We said it is the number of moles of solute. Here it is normality and hence we use gram equivalence of solute. So what is gram equivalence? Gram equivalence is nothing but given mass divided by equivalent mass. So gram equivalence is given mass. A mass is given. Given mass divided by equivalent mass. For easiness, just compare it with our number of moles. What is number of moles? In case of molarity, here it was number of moles. So here if we have to find number of moles, that is given mass by molar mass. Here it is gram equivalence, not number of moles. Here it is gram equivalence. So given mass by equivalent mass. There it was given mass by molar mass. Okay. Now here comes the term equivalent mass. What is equivalent mass? It is also nothing but equivalent mass is molecular mass divided by n factor. This equivalent mass, can you see? Okay. Equivalent mass is equal to molecular mass divided by n factor. Molecular mass divided by n factor. Now comes the next term. What is n factor? I'll tell you. So in case of salts like NaCl, n factor is the number of electrons involved. Okay. In case of acids, it is the basicity. For example, if it is a case of HCl, number of replaceable hydrogen ions. Okay, number of replaceable hydrogen ions. So in the case of HCl, it is only one H plus. H plus ion is left. So its basicity is 1. Hence its n factor is 1. In case of if it is sodium hydroxide, in case of a base, what happens? In case of a base, we take the acidity. That is number of replaceable hydroxyl ions, OH ions. Okay. So in case of NaOH, it is 1. So its equivalent mass. What will be the equivalent mass of NaOH? NaOH molecular mass is 40 divided by n factor, it is 1. So in case of NaOH, equivalent mass is same as molecular mass. Just divide it with the n factor. If needed, I will make a video for normality alone if you need. Then one more thing for elements. Elements are also there. So for elements, n factor is what? N factor is that valency. Clear? So now we have discussed all the concentration terms involved in this chapter solutions. So do well.